Yes, welcome to this session on bootstrapping Chef. By Chef, I mean Chef Infra. I'll definitely slip up and refer to Chef Infra as just Chef, but I mean that's what I mean. That's not the only thing that changed though after I pitched this talk. Not only did they change the name, but they also refactored all of the code around bootstrapping while I was writing it. But I think we'll manage anyway. It's much cooler now. Okay. So today's agenda. First, the first part is all about pulling apart the bootstrapping process and identifying all the different bits. And the second part is about the sort of challenges you're probably going to encounter in a large enterprise, especially a Windows-based enterprise. And we'll end with an oft overlooked thing, which is keeping Chef Client updated when you're done. So, who am I? My name is Tor Magnus Rakvåg, but Americans usually just call me Tor. That's probably much easier. I'm a senior engineer at Intility in Oslo, in Norway. I've been a certified chef developer since 2017, so I probably have to renew that soon. And I've also contributed some stuff to Chef Infra, mostly in Windows-related areas. So, bootstrapping. Let's look at what that actually is. It's very important to have a solid understanding of what's actually going on when we're bootstrapping in order to be able to create a solution that's tailored for your organization. Because if you're a large enterprise, you're probably going to have problems doing the out-of-box experience. So most of the info out there on bootstrapping is how to use the knife bootstrap command. Not a lot about what's actually going on underneath. So to illustrate that, I've chosen to show you the actual code that gets run when you run the knife bootstrap command. At its core, it's a couple of basic operations, which I'll go through one by one. I've removed a couple of things here. There are some sanity checks and such, but this is the literal code that gets run when you run knife bootstrap. This is also the new code from Chef 15. Which has been refactored by Mark Paradise at Chef. It looks really good now. Some highlights from the refactor, it's, apart from a ton of bugs being fixed, it also supports Windows right out of the box now, and it uses a common library underneath for remoting. So it supports WinRM, SSH, and actually other stuff as well. So there's no more plugin to actually get to bootstrap a Windows node. Okay, let's go through it line by line. Register client. That does exactly what it sounds like. It creates the client object and also the node object, except if there's a validator present, in which case it does nothing because the validator gets copied over later. We should also define here what the client and node objects are. The node object is the one with all the attributes, the run list, the policy, etc. And the client object is just an RSA key pair, which is used to authenticate the node to the Chef server. Connect just connects to the node you want to bootstrap. Previously, this was using knife SSH, only supported Linux and had a bunch of issues. Now it uses train, which is a library from the InSpec project, which abstracts away all the remoting logic. So now it handles all platforms. Now the next line, render template. That's the secret in how bootstrapping actually works. What that does is to take all the different settings you're either passing to the command or default values and compiles them in a giant script, which installs the Chef client, writes the keys you're going to use to the disk, deals with HTTP proxies, and so on. It's a very large script which deals with most edge cases out there. The next line is upload bootstrap. That just copies that script over to the target node. And the last line, perform bootstrap. That's literally just run that script. On Windows, it's cmd.exe/c, and then the path to the script you uploaded. So, summarized, bootstrapping, the flow in bootstrapping is first, you create a client key or use a validation key. I'll get back to that. You render a script, which does everything you want. Install the Chef client, write the keys to the disk, etc. You upload that script, and then you run that script. So I've been just talking about validators here. So what is a validator? Well, a validator is a special client which has permission to create new clients. So the idea is that all you need to do in order to create a new client object to set up the communication between the node and the Chef server is to give it a validation key. And then it detects it has no key on its own, uses the validator to create itself, and then it's registered. You also don't have to. You can auto-detect the name of the node using that strategy. Now, using a validator means that you can create a single script to bootstrap all your nodes. There are also a number of reasons why that might be a not so good idea. First, you're using a shared key, and that's pretty bad for auditing. Whenever you bootstrap a node with a validator, all the logs say is that the validation client created a new client. Nothing about who actually did that. Second, in a validator bootstrap, the Chef client has to create the entire node object on itself. And if that Chef client run fails for some reason, then it won't actually store any of the information you pass to it. It can't store its run list or the environment or policy name or policy group, because we're all using policy files now. And you don't really get a good error message either. The error message you get is something access denied. There's a hint that it might be because the node already exists, but it's just access denied. Looks like there's something wrong with the validator, but that's not the issue. And the third thing is that it doesn't really handle name conflicts. Oh yeah, sorry, just went through that. Okay, lastly, if you're using Chef Vault to store secrets, yeah, probably leave the lights off.
Leaving the lights down is better.
Yeah, that's probably better.
It is, because you can see the screen a lot better.
Yeah. Okay, so where was I? Chef Vault. If you're using Chef Vault and a validator bootstrap, you can't actually bootstrap it with a run list which requires access to any secrets, because the client doesn't already exist. So you have some chicken and egg problem here. So what you usually have to do then is to create or bootstrap it with a minimal run list, which does almost nothing, then give the new freshly created client access to that vault, and then you give it the full run list. So what's the alternative to this? Well, a couple of years ago, we got something called validator-less bootstrapping. And that simply means that instead of using a validation client to create a client, you use your own user key. Now, that means we can handle a bunch of edge cases, like name conflicts interactively. If it already exists, you can overwrite it on the command line. And you can also add that freshly created client to any Chef vaults you might have lying around. This also means that you don't have a shared key anymore, but it's also a much more privileged key. If you're just using your user key, you have access to do a lot more. So That's fine on your workstation, but if it's in some kind of pipeline, you have to be more careful about how that key might leak. Okay, so let's go through a simplified illustration of how the two different client creation flows work. First, let's go through a validator bootstrap. We transfer that validator to the target node. And by the way, there's a ton of more stuff going on. This is just about the client key itself. The Chef client starts, detects it has no client key on its own, but it does have a validator. So it talks to the Chef server. The Chef server generates a client object with a public and private key, and we store that on the target node. And now the client is registered and can talk to the Chef server. Okay, back to the initial state. But now we're using our own user key instead. First thing we do is talk directly to the Chef server. We create that public and private key pair. You can also create that private key locally if you want. That's not the default setting though. That's transferred back to the workstation, and now we do all the other steps, like give it access to a vault, for instance, and then we transfer that to the target node, and we have the same state, except we didn't use a validator this time. Okay, so some takeaways. Bootstrapping is a fairly simple process when you look at all the individual bits of it. You build a shell script which installs Chef, you create a client or give it access to create its own client, and it does all that. Knife bootstrap or similar actions is a push action. That is, we're speaking directly to the node we want to bootstrap. That has some implications about large environments and complex network topologies, which we will revisit soon. But now that we know what bootstrapping actually consists of, we can find out if we can use the official implementation in Knife Bootstrap, or we can re-implement those parts in a way that makes sense for our environments. Okay, so what are some challenges with this? Many people have challenges trying to bootstrap their environment. So there are probably hundreds of different ways this can be challenging, because if you have a large environment, it's very hard to deploy a piece of software to everything for a number of different reasons. So I'm going to go through some common ones I've experienced and seen other people experience, but your mileage may vary here. You may have completely different problems, in which case I'd love for you to tell them to me after the session is done. So what we want to do at its core is to run this script across our entire infrastructure, or at least the parts we want to be Chef managed. That script has to install Chef and put it into communication with one or more Chef servers, if you're using Chef servers, that is. So it's a fairly straightforward series of steps. So why am I talking about it as it was a really hard problem? Well, at its core, it's just a software deployment problem, like any other. And why can that be hard? Well, you might not have tooling in place already to deploy a piece of software everywhere. There could be no way to reliably do that in your environment. And you may even be implementing Chef to solve that problem. The default strategy of all the tools in the Chef ecosystem is also to pull all their dependencies from the internet. And I'm mostly speaking about Ruby gems here. So if you have servers without internet access, you either need an HTTP proxy to reach rubygems.org, or you need an internal rubygems mirror. You also need the Chef client binaries available internally to all the nodes you want to bootstrap. Now, complex network topologies, or Airgaps even, are probably the biggest source of pain when you're trying to deploy a piece of software like the Chef client. And that scales with org size and how many segments you have. Like our network, for instance, at Intility contains hundreds of different separate segments, and you can't reach one from the other. So deploying Chef is a challenge in that regard. There are also obvious security considerations here. We are, after all, talking about running a script across our entire infrastructure, and a script which by default anyway downloads something from the internet and installs it will probably make people with security in their title ask follow-up questions. So we have to be very mindful about what we're doing here. But if you're sitting here right now and thinking these aren't challenges in my environment at all, well then, very good. You probably won't have many problems deploying it. Or you could have some problem I'm not aware of, in which case tell me. So let's call out, I haven't really called out Windows yet, even though that's the central part of this session. But this problem is probably very Windows specific. And that's the problem around remoting. It's very common in especially, let's say, older Windows environments to not have a solid strategy around programmatic remoting. You might be able to RDP to a server, but you won't necessarily be able to use WinRM. We've had WinRM for years. I think that's from the XP era, but it's still viewed with suspicion in many areas. Am I feeding back, or does it sound okay? Okay. Yeah. So you might be in a situation where you have to RDP to that node and paste the script into the PowerShell window, and that's no good. So you could perhaps forgive people's suspicions towards WinRM, though, in some instances, because a lot of different instructions around the internet when you're trying to use WinRM with a tool instruct you to turn allow in an unencrypted and on and use basic authentication. And that's obviously a bad idea. It's also, there's a configuration problem here because different versions of Windows have had different default settings around WinRM. So you might have a bunch of servers with it on and a whole lot of other servers where it's not on. So let's look at some solutions to the problems I've outlined now. It's enough doom and gloom. This depends very much on exactly what your organization looks like. Like our org, which I mentioned earlier, has a network segmentation issue where it's very hard to reach anything with a push-based tool. So we've had to implement our own strategy around bootstrapping. Okay, some solutions. Before you decide on how you want to reach your nodes and bootstrap them, you should make sure that all of them can reach either an internal mirror of Ruby gems or they can proxy to the internet. You should also make sure that the install binaries, that is the Chef client install file, is available to all the nodes you want to bootstrap. You should also future-proof yourself here. When it comes to updating, you also want that binary to be available. So getting a solid strategy for deploying the Chef client MSI in Windows environments is a very good idea. I can recommend using a combo of Chocolatey and Artifactory here. It works very well.
What was that second one?
Artifactory. Or all you really need is somewhere you can reach that MSI, but Artifactory works very well there. Secondly, you should plan on a number of bootstraps or installs failing. because especially on Windows, we are running an MSI, and they fail for strange reasons all the time. So you shouldn't depend on the install working all the time. Okay. After you've done all that, I would very much recommend that you put as a step in your node provisioning process of bootstrapping it into Chef. Depending on how often you provision new nodes or recycle old nodes, this is probably the most critical step. If you get this in place early, then the rest of the process becomes a one-time thing. If you don't, you'll have a growing backlog of nodes which aren't already bootstrapped. So to take our pipeline, provisioning pipeline as an example, it deploys virtual machines in a bunch of different locations, but the first one was a pipeline which deployed servers to our VMware-based data centers. The first iterations of them were written in System Center Orchestrator, of all things, where we ran PowerShell scripts to clone VMs, and then the invoke VM scripts commandlet to bootstrap them. Now those scripts simply wrote keys to the nodes and all the config files. We're using validators for that. And the Chef client binary was already installed on the nodes or on the template, which we built using Packer. So we updated Chef client as part of that, and then just gave it to config. Nowadays, that's been replaced by a more advanced microservice web app thing, which also deploys to other clouds. But no, that's how we bootstrap new nodes. Now, you might be doing that manually, in which case, run the Chef client command. Next, all our new servers are being Chef managed, so what about the old ones? First, we have to find out if we can use a push-based strategy or a pull-based strategy. Now, these are familiar terms in config management land. Push refers to reaching out to the node and telling it what to do, whereas pull makes something available to an agent already in place. Now, push-based approach is, for example, using knife bootstrap to push config directly to them. If you have a high degree of network segmentation, like I talked about earlier, then that tends to get impractical because you have to do it once per segment. Enter the segment or air gap and then bootstrap everything in it. And if you have hundreds of them, then you have hundreds of different things you have to do. Whereas a pull-based approach is using an agent already in place. But you do have to write the entire bootstrap process yourself then. So if you can reach your nodes from a relatively low amount of separate places, then a push-based approach is probably the preferable method. That means you can use knife bootstrap right out of the box, and all you have to really worry about is how to map nodes to which Chef server or organization they're talking to, which policies they're supposed to be running, and so on. And if you can do that in a Windows environment, then very good work setting up a WinRM remoting strategy. You might also end up here anyway if you can't get the pull-based approach to work, in which case you just have a ton of work on your hands. So pull-based approach, this is an alternative to the traditional tell the node what to do approach, where you have some kind of pre-existing agent to deploy Chef. If that's proper deployment tooling like Octopus Deploy or some other deployment animal, then this will be fairly easy to do. But as long as you have some kind of system which can run a custom script, you can use that to bootstrap Chef. And it's a fairly straightforward process. Now, you should probably be using validators if you're using a pull-based approach, unless you have a very sophisticated way of pre-making every single client and storing them and assigning them to each node. You can also get pretty creative and hacky here. Any system which can run a script can be used to pull a Chef bootstrap you've written down, including GPO logon scripts for Windows environments. Now that has some weaknesses, obviously. Among other things, the node needs to restart to actually run that logon script, and you have to bring your own logging strategy. You also have to be very careful about the key, because that's going to be available to a lot of nodes. You should also be very careful that you've covered all your corner cases here. Otherwise, it'll get progressively harder to write a bootstrap script, which has to recover the previous failed one, cleaning up config lying around, old keys, old installs which may have failed, and so on. You could also use something like config manager if you add that on your Windows nodes. That's fine. It depends on how many different Chef servers or organizations you have, because it can get tedious to punch all those scripts in. Airgaps and network segments. I don't really have any good news here. If you have properly air-gapped environments or segments, you simply can't. You have to go in via VPN or a jump box or something. Then you have to repeat whatever bootstrap strategy you're using inside all of them, and that's simply how it is. If you can't break down the air gap or segment, then there's nothing to do. You just have to do it a lot. Okay, that's enough doom and gloom. Let's go on to a very important subject, which is keeping the Chef client up to date. If you're just rolling out Chef and don't have a strategy for actually updating it later, then you have to repeat that entire process. And if that's a very labor-intensive thing, then you don't want to repeat that. So, if you're on Linux, or mostly Linux, this is fairly easy to accomplish. Chef can update itself with a cookbook called Chef Client Updater. On Linux, it usually works fine. So try using that, unless you have some other agent, in which case that's probably your solution. On Windows, this is much harder to accomplish. Due to some fundamental differences between the two operating systems, you can't just remove all the files right from underneath a running process. So for Chef Client to update itself, it can't be running while you're doing it. So you have to spawn a separate process which runs later when there are no other processes which are touching files inside the Chef infra install directory. That includes other processes like AppLocker and such. So this causes a lot of pain when upgrading on Windows. What we need to do is create a separate process which runs after Chef Client is finished running, and it also has to be elevated. Now, this is possible, but there's no built-in way to do that. What we usually do when we want to do that is to use the task scheduler. Now that gives us a separate process to run the upgrades, and it's also elevated for historical and practical reasons. If we have to use a separate credential, we can also do that, and the task scheduler can run any command you wish to run. Feels very hacky to do this, but that's the generally accepted pattern. And this is also what Chef Client Updater does on Windows. It creates a separate task which upgrades Chef, and does that using built-in Ruby libraries. Unfortunately, that's proven to be very error-prone on Windows, that cookbook that is. There are continuing efforts to improve the process, but the code has gotten very confusing because there have been lots of attempts to patch different edge cases, so we might have to look at refactoring that at some point. So our strategy at Intility to upgrade nodes now is that we've created our own cookbook, which is exactly what we need. It also uses the task scheduler strategy. So if there's an update available and we want to update through an attribute, it creates a scheduled task which simply runs choco upgrade chef client -y. Also restarts the event log and stuff to get the event log's hands off that chef log DLL file. That works very well for us. It may not work for you, but it's much easier to write your own at this point if you're trying to use chef client to update chef client, because you don't have to think about everyone else's corner cases. Now, I've gone through this entire talk without mentioning Habitat, which is probably a better strategy for updating Chef than using Chef client itself. This is part of what's being called effortless config. So I very much recommend that everyone go to the effortless config session in LWAB today at 3 p.m. I think. Now that goes all the way with Chef Habitat and also packages the config in the package, but you could, in theory, just update Chef client with Habitat and still have it talk to a Chef server. Now, the reason we're not using it is because we have a lot of Windows nodes, and there's not yet an official Chef client Habitat package for Windows. There is one for Linux, but we're still waiting on that. I'm told that will happen soon, though. All right. Are there any questions I can answer? Yes?
So you mentioned that the validator only has the ability to create the node within the Chef server. Does that mean at that time of creation you can't also assign a run list? So would you have to run the Chef client twice?
Well, the validator, so the code path inside Chef client when you're using a validator is that it creates the key, the client key, which can modify the node object, and then it switches the key it's using when that new key is created. So yes, it talks to the Chef server using the validator, creates a client key, and then it just starts talking to the Chef server with that new key instead. So then it can modify its own node object. Okay, any more questions?
Out of curiosity, you mentioned that a lot of the different methods for deploying the Chef client, and you mentioned some scripts with some servers that already have the client installed, and then on boot up they run these scripts. Are those scripts available on GitHub anywhere?
Sorry, which scripts are you talking about? The built-in ones, or?
Bootstrapping after deployment of, say, an image, machine image.
Right. No, they're not available because they're fairly ugly, but I can probably make some available. It's basically just writing a bunch of text to the disk, so it's, we can probably find something. What you could do is look at the Chef Bootstrap template that's built into Chef and just replicate that and use that. That script handles everything you might want it to handle. Yes?
So if the Bootstrap fails, then is it manual remediation, or is there a process for trying to get to go again?
Right. It can fail in a lot of ways, though. But if it fails, If the chef client run fails in a validator bootstrap, is that what you were talking about? Yeah. Then the client exists, but there's no node object. So if it won't have, next time it talks to the chef server, it doesn't have a run list. So you have to remediate that manually. Yes. Yes?
Just out of curiosity, what tool do you use to actually provision your servers?
We're using a built-in, we're using a entirely custom program. We've used different kind of pipeline software, that works fine, but we have an entirely custom program which provisions nodes. That just talks to some APIs. Yes?
You mentioned using Chalk. Are you using that just for upgrading, or is that part of your bootstrap?
That's part of our bootstrap. We also build the chef client into all the new images, but it's also a part of the bootstrap to upgrade it if there's one available in our internal mirror. So that's both for installing and upgrading.
Can you package a custom Chalkery package of chef client?
It replicates what the official one does, except it uses an internal mirror. It's very simple. It downloads an MSI or downloads the MSI from an internal mirror and then runs, I forget what the commandlet is called, but the default install of this thing in Chocolatey. So it's very, very simple.
Are you installing the chef client as a scheduled task or a service?
Schedule task. I wouldn't recommend you running chef client as a service.
It's no longer the default.
Yeah, that's right. It's been task for I think a couple of years now. It's been the default or the recommended path. That's related to the chef running service locking the files underneath it problem. So it's much easier if it's just a task. All right. Well, if anyone has any different challenges bootstrapping, I'd love to hear about it. But I think that's it. Thank you.